international aircraft. Low-level wind shear advisories are in effect. Microburst alerts are in effect. Airport wind 31051, gust 57. November 200 Golf X-ray, roger. We may evacuate the tower here in just a second. Wind 32051, gust 63, and I'm hearing some humming coming from outside. It's going to be a while. The area of precipitation extends at least 5 miles west of the airport.
A very active evening last night in the southern plains, and that area of thunderstorms has moved eastward into the southeastern states. I've got some interesting material to show you from those thunderstorms, but let's take a look at what we have first for today. A powerful weather system moving through the Midwest states. The lowest pressure ever recorded at Terre Haute, Indiana, 979.5 millibars, or 28.92 inches. And that's what it looks like on the METAR report. This is the official source of observations, 28.92, which is a full inch below the typical barometric pressure. And the sea level pressure, there it is, 979.5 millibars. Most of the precip around that is in the form of rain, but some of that rain is transitioning over to snow in places like Chicago, South Bend. There it is on the radar at Fort Wayne, Indiana. Most of this is in the form of rain. Up north, it's snow. It looks pretty similar, although it's got more of a glaciated appearance up to the north, more striated. But if we go over to the correlation coefficient, you can definitely see a difference. Correlation coefficient is one of the dual polarization products. Up to the north here, you can see some very high correlation coefficient values that corresponds to snow, and the more noisy lower correlation coefficient values in yellows, reds, and so on, those are going to correspond to rain. Also, some embedded thunderstorms near this low pressure area. They've had wind damage in some parts of central Illinois, around Champaign, for example, and a very well-developed comma head associated with the Colt conveyor belt, producing some heavy rains around St. Louis. This is the HREF ensemble forecast for 1 hour snowfall. You can see reds up there in Michigan corresponding to 2.5 inches per hour. And as we go into tonight after dark and towards midnight, that spreads up towards Toronto, Ontario, and into upstate New York. Some heavy snows coming down around Saratoga Springs up towards Plattsburgh, and by daybreak, that spreads up into New England. And then as we go into the afternoon, it's out of the picture. Down in the southeastern U.S., heavy thunderstorms approaching Atlanta, Chattanooga, and there are some heavy winds associated with these storms. Some of those winds last night and early this morning gusting up to 70 miles an hour across parts of Tennessee. Those storms have rapidly moved eastward, approaching the Atlanta area. Looks like it has cleared Chattanooga, and it's moving into places like Asheville and the Blue Ridge Mountains. Numerous severe thunderstorm warnings out for these cells. They do look a little bit raggedy and disorganized, but definitely the potential for downburst winds within all of these cells. A little bit more disorganized as you move up towards Knoxville, but one little cell about to cross over into Virginia is looking a little bit severe. The Wilmington radar, well, this is getting a little bit closer to that dry slot coming in from the southwest. Some of these cells also have the potential for strong winds. The instability decreases as we move to the west. This is mostly the cold conveyor belt area, the dry slot working into Kentucky and southern Indiana and southern Ohio, and up to the north. That's that area of snow we talked about. Let's go just a little bit further to the west. And there's the Evansville radar getting close to the tip of that comma head, and a lot of the precip back here, it's got that striated look, so that's obviously going to be snow, or at least snow just off the surface. And you always want to double check that with the surface plots to get the full picture. And certainly, yeah, all the way down towards Mattoon, Danville, well, just west of Danville, and south of Springfield, that's going to be the snow area. Some of that also showing some lightning within the precip areas. But down to the south, This is all in the form of rain. But certainly some very high winds. You can see sustained winds at Champaign, 31 gusting to 45, and 36 gusting to 49 at Mattoon. And there we have some of those large flakes coming down around Bloomington Normal, Illinois. In the south central U.S., a rather nice day, westerly flow, and this is coming mostly from the western U.S., so there's been some downslope flow, some strong heating, and temperatures are rather mild, 50s and 60s. But yeah, some major weather coming out of that region. Yesterday, we talked about that back on the Wednesday show. Major storm system, very low barometric pressures. In fact, around Dallas, some of the lowest pressures I've ever seen in that area, near 29.20 inches. And a lot of dust coming in on the backside. And some of that dust worked all the way down towards Del Rio. And we go back to yesterday at 22Z, about 4 p.m. You can see those very high winds out there around Midland, all the way down towards Del Rio, where it was 94, and further south, 100 degrees. And there's some of the high temperatures in advance of that system yesterday. Strong downslope flow, dry conditions helped that mercury rise up above 100 degrees. And Falcon Lake recorded 104 degrees. That appears to be the earliest 104 degree reading ever recorded in the United States. Here's what the wind gusts look like in miles an hour. 70 miles an hour around Del Rio, and lots of 60s across the Permian Basin. These are the wind gusts around the Dallas-Fort Worth area. Yesterday, that's Fort Worth. There's Dallas, and this is a mix of federal and hobbyist and private Mesonet data, just kind of a huge source. So there's a lot of bad data mixed in here. Like, this is probably bad, that as well, and that right there. So you do have to take this with a grain of salt, but a lot of the very high values are coming out of the federal sites which have better exposure. So 76 miles an hour at Dallas Love Field, 71 at DFW Airport, 77 at Meacham Field, and 78 at the Joint Naval Base at Fort Worth. And social media buzzing with these clips of very intense hail in Sherman yesterday, about 3 to 4 p.m. You can see that right there. Pretty impressive. Let's take a look at that storm. Let's take a look at the setup yesterday at 2:30 p.m. What we had is the main forcing located out west. This produced the large convective weather system and the high winds later on, about 4 hours later. Initially, we had the hail associated with the strong warm air advection. So these are a couple of those cells. This produced a little cluster of severe weather in the Red River region. So starting out, this is going to be the big hailstorm, although these were both capable of producing hail. We run that forward and we see this hailstorm take more of a right turn, heading right for Sherman. Let's zoom in even more and look at that. You can see that inflow notch right there. So it's getting some good fuel feeding into that storm. And let's see, there we go. Definitely has that look of a hailstorm, and then it rolls right into Sherman, and we're starting to get those 76 dBz values, that aqua color associated with intense hail. So that tracked right over the city. Let's back that up just a little bit and look at the maximum estimated hail size. There it is. That's going to be about 2.5 inches, and you're going to see the grays take over right there. So that's going to be baseball-sized hail, probably even a little bit larger, and that tracks right over Sherman. So I'm going to take this back to 3:44 p.m. Now, Sherman is located right there. You can see one hail core right there over South Maid. However, what's going on in this area? Let's take a look at a cross-section, and I'm going to draw that right through that inflow notch, just like that. Now, down along the low-level scan, we can see, yeah, there is some hail out to the west, but aloft, a considerable amount of hail aloft. That's 70 to 75 dBz's. That's all going to be very large, wet hail up at 20,000 feet. So that's definitely an ominous indication. And another way we can see that is to go up to the higher tilts, up to 1.8 degrees, and voila, yeah, that's going to be some very intense hail right above the surface. And at the low levels, let's compare that. Yeah, you'd be thinking, oh, there's nothing going on. You're right there in that notch. But you might step outside and hear that hail roar up in the sky, the roar of hail. I've only heard that several times in my life, but it is certainly a ominous sound. So eventually that hail did make it to the surface, and yeah, there's the rest of it. Major hailstorm across Sherman with those 76 dBZs coming right down to the surface. Some of this hail was also observed by the Oklahoma City radar. We look down to the south, there's that storm at a pretty far distance, 120 miles, being sampled at 15,000 feet. But let's zoom in and check this out. And we roll that forward. You can see a 3-body scatter spike, a TBSS, extending outward along the radial from that hailstorm. And that's a good indication that there's hail within that. You can see none of the other cells have anything like that. It's unique to this particular storm. And the way we get that spike is the radar energy hits that hail, which is an excellent reflector. It goes down to the ground and reflects back up to the hail and back to the radar. So that kind of extends the trip that it takes, more of a long distance, and the radar sees that as a longer range. So this is actually a false echo, but that's indicative of the scattering taking place within that hailstorm. And then at 6 p.m. we had the main line roll into Dallas-Fort Worth. Let's zoom in and check that out. What we see here is a very prominent outflow boundary out ahead of the storms. That's it right there. Let's run that forward a little bit further, and you can see some more of that shows up very well. And that tends to be an indicator that the risk of significant tornadoes is a lot lower, because when your storm is gusting out, it's hard to get that balanced inflow and outflow structure. You can still get some quasi-linear convective storm or QLCS tornadoes going. Those tend to be a little bit briefer and not quite as strong, but they can still produce damage. Now I'm going to switch over to the velocity, and there you can see that outflow boundary a little bit better. And I'm going to zoom in a little bit further, and as we roll that forward, you can see it takes on a bowed structure in some areas, and those are definitely areas to keep an eye on. You can get some locally heavy winds close to those bows. So that's one right there, another one right there. It is kind of hard to sample the wind field with the radar being parallel to the storm. This is looking up the line, so you're only going to get some good sampling of the ground relative winds to the southeast, where you're at an angle to the line itself. But even there, yeah, some very high winds close to the ground. That's going to be 60 knots at 1,200 feet. So very likely that would support some winds anywhere from 50 to 80 knots at the ground. All right, let's move on. I can see that clock ticking there. I want to get this video out at a reasonable time. Up to the north, a little bit more cold air filtering into the Dakotas, but temperatures in the 30s. A little bit of snow flurries and heavier snow showers in northwestern Colorado. In the southwestern U.S., a nice day for a change. Temperatures in the 30s, 40s, and 50s, but they are expecting another storm this weekend. Snow levels will come down to 2,000 feet in parts of Northern California, and locally, maybe down to 500 feet in the far north. At Arcata, in northwestern California, a beautiful halo. This comes from the Weather Service there. I'm not exactly sure who took the picture, but it is spectacular. And this is an indication of considerable moisture in the upper levels. More moisture streaming in ahead of the next system. And we'll look at the details on that shortly. Heading up the coast, we've got that onshore flow, and that means rain in the western part of Washington and Oregon. Heading up north, snow continuing around Juneau and Skagway. Large band of snow across Yukon, southern Alaska, and heading up into Alaska itself, temperatures are back down once again, minus 36 in some parts of western Alaska, and lots of areas below zero. So a bit of a cooling trend taking place there. In the Arctic in Canada, it seems like every day it's been super cold there, but we've seen an unusual warming trend, and you can see the gradient, the isobars driving in from east to west, and that's carrying the Gulf Stream waters, the warm air masses associated with that, westward towards Baffin Island and Quebec. And we can see temperatures up to 18 degrees at Frobisher Bay, which is now Iqaluit, and up to 2 degrees at Longstaff Bluff, and that was a very cold part of the country just a couple days ago. This whole area was getting minus 20 to minus 30. And in Greenland as well, temperatures coming up quite a bit. I think that is 54, can't really read it, and 50 degrees, which is definitely very warm in the southern tip of Greenland. And dropping down south, there goes our outgoing high-pressure system. Temperatures cold, but kind of on the mild side for them right now. And this next system will be coming up through Canada. And Environment Canada does have the watches and warnings out for that. They're looking for 8 to 12 inches of snow around Toronto out to Kingston, and that will track into New York later tonight. So before we head into the AWIPS charts, I think Pivotal Weather is a great place to look at this precipitation building into that area. So it looks like a transition line in southern New York out towards Lake Erie. We get snow up there around London, Toronto, out towards Albany. This is going to be about 10 p.m. Eastern, and it all spreads into New England as the evening goes on. And you can see a transition from frozen to liquid precip across much of southern New York and Massachusetts and Connecticut. And looks like by daybreak, rain across Rhode Island and Connecticut. And then we get the wraparound later, cold air advection, but that is associated with a drying trend as well. So snow during much of tomorrow, and that gradually shuts down as we go into the evening. Man, there's so much to look at. So yeah, 15 minutes in, we're finally getting to the upper air charts, but I'm going to make this kind of quick. Now we've switched over to 250 millibars because we're getting into March and April. That's the transition season, and with that we start looking at 250 and 200 millibars for our forecast. So we start out with troughing in Texas this morning, and that lifts up into the Midwest region, and that's associated with that precip moving into the northeast U.S. Another trough dropping into California. That's going to be our next bit of weather. A lot of the vertical motion field heading into Northern California and then spreading into the Rockies as we go into Sunday. And then we see another trough dropping into the backside and helping to keep this long wave troughing in place. So continued unsettled in that part of the country. Out ahead of that, some shortwave troughs working into the Great Lakes area. And finally, we get that trough moving eastward as we go into late next week. So it's going to be kind of a stagnant weather pattern between now and next week. However, this trough for March 11th and 12th, highly amplified, so we may see some heavy rains in parts of Texas. And look at that right there. Looks like a mega block. You can see that familiar shape of the Greek letter omega. That's associated with a cutoff high just south of Anchorage. So we're looking at March 11th. And then going into the extended period, middle of March, it looks kind of like a cold weather pattern for much of the country. Let's head to some of the other charts. And I thought this was a good one. This is a 10-day animation. I'm just kind of repeating it over and over, and you can see the tendency towards ridging around Alaska and the tendency towards troughing in the west and central U.S. And we're kind of stuck in this pattern, and so we're going to get kind of the same systems moving through one after the other. This is a really good chart. Looks pretty complicated, but I'll show you how easy it is to use. This is 500 millibar heights and vorticity. There's the date right there, so that's going to be UTC time 4th of March at 0Z. That's going to be about 7 p.m. Eastern. So a strong shortwave there in Ohio, and the strongest lift usually found just ahead of these shortwaves. So that area right there around Pennsylvania, Akron, and up towards Toronto, that's going to be the strongest lift. And that's where you're going to be seeing a lot of the clouds and precip. Another area, Wyoming, that's a shortwave as well. A lot of the lift right out ahead of it. And we're going to focus on this area out west. So let's take it into tonight and tomorrow. Well, for one, there's our outgoing system spreading the snow into New England. But here comes our next disturbance out west. Moving on to the California coast tomorrow. So that's going to be tomorrow about lunchtime, about I think 11 a.m. or 12 noon in the Pacific. So the strongest lift right there, starting to make its way inland, and a couple of chunks of energy crossing the Bay Area, Sacramento, and with that, we're going to be seeing convective precip as well, with a strong upslope and the cold conditions aloft. You can see minus 36 there at 500 millibars in Northern California. So all of this a good recipe for heavy snows in the mountains. And eventually it will move into the Rockies. That's going to take a little while. Some of it affecting the Great Salt Lake and Wyoming right there. But eventually, when we do get the trough making its way inland, that's going to be this little ball of energy for early Thursday, moving into Los Angeles. So once again, our viewers like Ron Chalfant will be getting some more precip, and that will spread into Arizona, where some of our other viewers are. So Thursday and Friday, those are going to be the big days, and then it will make its way into Texas. You can see the very deep southerly flow, which will tend to mitigate some of the severe weather risk. That'll give us more of a unidirectional shear profile, so maybe slightly less chances of severe storms, tornadoes, hailstorms, that kind of thing. It all depends on how much moisture we get and how strong the cap is. Typically when I see this pattern, though, I start thinking of squall lines and not much instability. You can see most of the desert air heading up north, and that means not very much camping in East Texas and eastern Oklahoma. So you tend to get a lot of cell competition and a lot of MCS activity. So we're not going to count our chickens until they're hatched with that. There still could be severe weather potential. We'll just have to break it down as we get into late next week. Anyway, a lot of the energy heading up to the Ohio River Valley, channeled flow through Texas and Louisiana, and in the wake of that, probably some very cold air coming in the back. And we've run past 20 minutes, so I'm going to have to stop for now. I want to thank our newest Patreon supporter, Dennis Woods. Thank you very much, and I hope you all have a good evening. I'm going to leave you with some footage from Greg Payne showing the dust storm out in the Texas Hill Country west of San Antonio. So enjoy, and we'll see you all next week. Take care. Bye-bye.